Hi there. My name is Christina Hastenrath, and today I'm going to speak about GraphQL endpoint and give you an introduction to GraphQL security. But first, who am I? My name is Christina, and I'm a software engineer at Postman. I grew up in Germany and now live and work in beautiful California with my wonderful husband and 5-month-old son. Why am I interested in GraphQL security? My interest in API security was sparked when I cut the head of our WordPress blog and built a Gatsby app on top of it. I used a plugin that was called WordPress GraphQL to connect the headless CMS with Gatsby. Before going live, our security team ran tests and discovered that the GraphQL endpoint actually revealed the email addresses of authors in some instances. Since this was a third-party GraphQL API, I reached out to the creator, Jason Ball, and together with the really great WordPress GraphQL community, they fixed this vulnerability. And I got interested in the security part of my own GraphQLs and also of third-party GraphQLs that we were consuming. So now I want to share with you how you can start with your GraphQL endpoint security. What am I going to cover today? First, I'm going to look at the building blocks of the GraphQL schema and show you how hackers, pen testers, and bug bounty hunters go about retrieving the application data thereafter. I then want to share some real-world examples with you and showcase how important it is to secure your own GraphQL endpoint and verify that any third-party GraphQL endpoints that you are consuming are properly secured. I will then move on to give you some pointers on how to start securing your own endpoint today. There's no one-size-fits-all solution, and mix and matching different approaches can help you secure your GraphQL API and minimize the risk of hackers exploiting your application data. So let's first of all take a look at the GraphQL schema, the SDL and root types. GraphQL has its own type system that defines the schema of the API. In order to write a query, GraphQL uses the syntax called SDL, which stands for Schema Definition Language. This schema defines how the API interacts with the backend. The 3 root types of this schema are therefore queries, mutations, and subscriptions. They describe what operation you intend to do. GraphQL does not have HTTP requests like REST APIs such as get, post, or delete. But since queries are used to retrieve data, it is similar to a GET request. Mutations are used for state-changing activities or modifying the data and are therefore similar to a post, put, or delete. And subscriptions can be used for real-time updates. One example is the cryptocurrency market, where you get real-time ratio updates between the crypto and the fiat. Now that we know what root types there are, we can go ahead and look at what the request and the response look like. So the request example here is a query that has a field called cat. You can provide arguments if you want to. In this case, the argument is name and the value is snowflake. Then we define the subfields. In this case, the subfield is called breed. So we are requesting from the front end to go and fetch us the breed data of the cat with the name Snowflake and only that data. We might have more information about the cat named Snowflake, but we only want to know the breed in this case, and that is the power of GraphQL. Let's take a step back and look at what GraphQL is. GraphQL is an intuitive query language that fulfills queries in an application to fetch data. When we implement GraphQL, we need to add support to the client side for the GraphQL query and to the server side so that it responds to queries. On the front end, we have the GraphQL client on our laptop, phone, or iPad, or other device that can show the /graphical endpoint. Let's say we have a mutation that wants to update a particular data point or post body value, for example, a name value pair. A name value pair is called a field. The field might require information from the backend database. In a simple Lighthouse application, resolvers then bring that data from the backend, but this is out of the scope for this talk. In contrast to REST APIs, GraphQL has a single endpoint and a query is being sent from the front end to the server. As seen earlier, the GraphQL schema is defined by queries, mutations, and subscriptions, and the API endpoint does not change when either of those requests are being sent. The endpoint stays the same, and GraphQL funnels all the queries through one endpoint. In contrast, REST APIs, which have multiple endpoints that are based on the app entities. Therefore, the more complex the entities of the app are, the more complex and therefore more expensive the REST API endpoints are. Looking at GraphQL's strengths and weaknesses. Some of the best parts about GraphQL are that it is efficient in fetching of data and needs a lot less development and maintenance on the server side for every API call. Unlike REST APIs, which bring back the entire menu in a restaurant, you can choose the dish that you want to eat with GraphQL. For REST, you need to run several requests to receive different data points, and the developer has to create several API endpoints to serve the data. In GraphQL, you run a single query that performs multiple operations and gets you all the data you need, which is less costly on the network. GraphQL is also self-documenting and easy to transfer and to learn by new developers on the team. Also, REST APIs need their versioning maintained and documented. This is not so much the case for GraphQL APIs. Another advantage is introspection, which is a query that performs an operation to pull all the information from the backend schema via SQL language structure. So introspection will allow the hacker or pen tester or anyone else to get the information on all the queries, mutations, types, and subscriptions and the entire schema structure. As I mentioned earlier, the client has to share information about the API. The graphical is a client-side IDE developer console, which is commonly accessed by /graphical. Of course, GraphQL also has a couple of weaknesses. One of the disadvantages of GraphQL is the query complexity and the query depth. Since GraphQL can perform multiple operations within the same query, this query can become quite complex. Rate limiting and timeouts are also common issues across all types of APIs, and caching, because if, for example, authorized responses are stored in cache, then unauthorized requests may retrieve the cached entries without checking the backend if this request is really allowed. The GraphQL server needs a logic to incorporate cache retrieval logic to protect access control of the backend. So why do I need to secure my endpoint? Malicious agents, hackers, or even not malintended users can use a GraphQL API to extract data from the backend or the infrastructure of an application. As we will see in our use cases, leaving your GraphQL endpoint unsecured can potentially expose private sensitive data or even worse. Are there best practices? GraphQL is a fairly new kid on the block, and there are no best practices yet. The GraphQL specifications also do not give any either. So let's look at the most common vulnerabilities that apply to GraphQL APIs. Many of those apply also to REST and other APIs. The Open Web Application Security Project is a standard awareness document that shows a broad consensus about the most critical security risks to web applications. In GraphQL, those are introspection, SQL injection, batching attacks, denial of service attacks, brute force attacks, and broken object level authorization. Now, there are many more, but these are the most common, so I want to walk you through each one of those. Let's start with introspection. Introspection is a query that performs an operation to pull all the information from the backend schema via the SQL language structure. So introspection will allow the hacker to get the information on all queries, mutations, types, subscriptions, and the entire schema structure. When I started looking at GraphQL security, I asked myself, how does a hacker start? Like, where is the starting point? And the easiest way to start is with introspection. So I want to show you how easy it is to actually use it. There's this wonderful GitHub repo here from Swiss guy called Payloads All the Things that gives you the query, and I'm going to show you where it is. It's here. And if you just scroll down a bit in the repo, you can find the introspection query here that you can just copy. And I'm running a vulnerable GraphQL API in Docker on my local machine. So it's a very simple GraphQL API. And I can paste in now my introspection query and run it. And we will get all of the data, my entire schema, everything from my own GraphQL API. Here on the top in the docs section, you can then see the queries and the mutations and anything else that has been defined here. Now, I'm a very visual person and I like to see how things connect. So what I can do is that I can actually use a tool in order to visualize my business logic of my GraphQL. So I can copy the output of my introspection and go to a tool that's called GraphQL Voyager. In here, I can now paste my introspection output, display, and here you can see visually my API. You can see how all the fields connect to each other, how maybe we could go into loops with queries, building out different queries. Now, this is a very simple API. GraphQL Voyager also gives you the schema of actual businesses. So you could take a look at the Shopify storefront, for example. And here you can see the GraphQL, how everything connects. So this can give the hacker or the pen tester or bug bounty hunter or anyone who's after the business logic a pretty good view on how to create mutations or how to try and get sensitive data that they might be after. Now, how can you protect yourself from anyone exploiting your GraphQL API by introspection? You can define when introspection is allowed in the application, for example, by using service endpoint fuzzing. That's also a common practice in REST APIs. When using an Apollo server, you can also disable introspection in production by adding environment keys, so that introspection is allowed in development but disabled in the production. Or you could also use this npm package. And here on the side, I have a small example of what that would look like in a Node Express environment. You can disable introspection there. And it's also important to mention that the GraphQL endpoint might not be at the /graphical endpoint. A developer can also nest this URL structure. You could also have /API/graphical or /GraphQL/console. There are a myriad of endpoint ways, and it's important that you know what the actual endpoint is. Okay, so moving on to another common vulnerability called SQL injection, which is essentially a manipulation of SQL queries that the app sends to the database to get sensitive information, update, or even delete data. In GraphQL, the developer is responsible for the security, and GraphQL itself will interact with arbitrary code and does not have any measures to prevent any attacks. So any field with a string type is potentially vulnerable for string injection. In the first example, you can add a single quote to the type argument in order to cause a MySQL syntax error. The application actually might not throw an error, so therefore blind, time-based, and out-of-band SQL injections can also happen. So let's say that it has thrown an error. In the next step, you can then take that HTTP request, save it and input it into SQL map, or you can construct a SQL injection by hand. The second example here on the right shows a SQL injection via union select. Let's say a query to post is controlled by a resolver with a string concatenation SQL request to the database. The SQL injection with union select is interpreted as executable code, and the user's ID, name, and password would be returned. In order to prevent SQL injections, you can always assume user input data is insecure. Apply input validation from queries, mutations, and subscriptions. Update the resolver code You can also update the resolver code in order to use only prepared statements with parameterized queries and escape all user input and enforce least privilege. All right, moving on to batching attacks. Batching attacks send multiple queries or mutations with a single GraphQL request and are mainly used to bypass rate limits and for user authentication abuse. A mutation that can update user authentication needs to have a limited number of attempts set. Otherwise, an authentication request with thousands of different email password pairs can be sent at one time. And on the right-hand side, you can see an example of 3 different email password pairs being sent, and the second one actually brings back the correct token. A batching attack also allows to bypass OTP or one-time password authentication by batch sending all token variants in a single request. A valid token could be found and the hacker or pen tester, whoever sending the request, can be logged in. What can I do? Since only a single large request is actually used for this, such a brute force attack might not be recognized and needs to be handled in the business logic. So you should think about your business logic and validate the user input and limit the number of attempts on the web server side. Denial of service or resource exhaustion are nested queries that turn into loops. When a GraphQL server is in place and multiple depth queries are crafted, the backend server has to process a lot, and some queries can also go into loops. You can see that, for example, we saw in the GraphQL Voyager Shopify storefront, you can loop through queries. This can be by design, and it can be exploited. In order to secure your API against denial of service attacks, you can add depth limiting to incoming queries, pagination to the data that is being returned, and timeouts to the application and the infrastructure layer. Broken object level authorization poses a risk because authorization is not applied to data as it should. Therefore, it allows access when it should not. The object here means a value, such as a blog post that contains the author, title, email address, or a group of values, such as social media posts of one author. The attacker can write queries to get the IDs of objects and then access the data of other users. It is important to write code that performs authorization checks on the requests. You can confirm identity with access tokens or secrets, and you can implement access controls on all endpoints that actually require privilege. It's also a good idea to use unpredictable IDs such as GUIDs. I now want to move on and show you some real-world examples. Arunes gave a talk on offensive GraphQL API exploitation. He is a pen tester, and he noticed that a company had exposed a mutation which was not intended to actually be public. It looked like this: a super secret private mutation with a standard input and standard output. Arun ran the endpoint through Introspection, which is a tool that generates queries and mutations from a given schema, and found out that this mutation allowed a user to perform a mutation on the database records. So for clearing purposes, the company had kept this request in their staging environment for cleanup tasks, and they accidentally also left the mutation in the production app. So a hacker could now have crafted a mutation, sent the query to the database, cleared it, and wiped all the data. It is that serious. In REST APIs, there are internal and external APIs, but in GraphQL, you really need to think about your business logic and set the correct configuration in order to protect your endpoint. The next example is a talk from Somdev Sangwan that he gave in June, and he discusses how he found a way to use the autocorrect feature in GraphQL as an attack vector. As you can see in the image, when typing the wrong subfield, GraphQL will give you a suggestion on an existing subfield, name or ID. Somdev gets into great detail in his talk and shows how he built a script that allows attackers to discover the schema even after introspection has been switched off. In short, he observed several things. First, that if, for example, the input is 6 characters long, the input will get autocorrected if it is 3 characters different from entry. The second observation was that the multiple field names actually get corrected. And his third observation was that the autocorrect is case sensitive, which dramatically increases the character combinations. This means that once field names have been enumerated, the arguments, types, and subfields can also be enumerated. Based on these observations, he wrote an algorithm, and that allowed him to brute force attack his way by using the autocorrect feature in order to obtain the application data. And the last example that I want to share with you is a very real-world example from Instagram's GraphQL API. Mayo Farte found a bug in the object level authorization in the Instagram GraphQL API, and Facebook actually paid him $30,000 prize money because he found it. And what he found was that any attacker could get access to private and archive posts, stories, reels, and IGTV of other users without even following them, only by knowing the media ID of the resource. This is real life impact, and it could have affected anybody, but this has now been fixed. So where can I start with my own GraphQL API? Unfortunately, there's no foolproof method, and you might need to mix and match protection methods for your GraphQL API security. You can start by disabling your GraphQL endpoint from the domain. You can create your own schema and avoid auto-generated schemas. You can validate user input, authenticate and authorize, never trust user input, and prevent denial of service attacks. You can enforce maximum query depth to avoid cyclic graphs from being exploited. The server then accepts or rejects a request based on its depth, and the server is not loaded additionally because if the query does not pass, it does not execute. You can enforce the query complexity because some fields can be more costly to execute than others, and you can define how complex these fields are and then set a maximum. A query will therefore not execute if it does not pass. However, this is hard to implement perfectly and needs to be maintained. Also, mutations are hard to estimate. Timeouts can help you defend against large queries because the server only knows the maximum time allowed for a query. However, damage can already happen before the timeout, so timeouts can be used as additional protection. You can also enable throttling on server time and complexity. Where can I start with GraphQL API security? I can recommend getting your hands on and learning by doing. There's some great labs out there. One is the GitHub repo Damn Vulnerable API by Dola Fari. It's an intentional vulnerable implementation of Facebook's GraphQL to learn and practice GraphQL security. GraphQL Security Labs is another GraphQL lab that guides you through the most common vulnerabilities and gives pointers on how to fix them. You can use Postman as a GraphQL IDE or client and import your schema and use the autocomplete function. Save your APIs and your collections and start testing. And How to GraphQL has a great tutorial on security and walking you through different security measures. There are a couple of tools that can help you. Stackhawk helps with testing of GraphQL APIs. They have some great webinars on how to get started. And I have a couple of resources here for you. And that completes my talk. Thank you so much for joining. Bye.